Hi guys, this is Mr. Urrego, and today we're doing laws of exponents, or rules of exponents, or property of exponents. They're kind of the same thing, all of them. But the first thing that we need to do is to talk about a power, x to the second power. The x is my base, the 2 is my exponent, the whole thing is called a power. So let's write a couple of them. If I have x to the second power, that means I have x times x. If I have x cubed, or x to the third power, means I have x times x times x. X to the fourth, you get the idea. Times x times x times x. So 4 times. X cubed, 3 times. X squared, 2 times. X to the first power, only once. So the exponent is telling me how many times is my base multiplying itself. X to the second means x times x, not plus, x times x, all right? And so on and so forth. Now from here, I can analyze and I can distinguish one rule, which is the product rule, which is when I have 2 powers with the same base, I add those exponents. Let's go backwards over here. We said that x to the second is the same as x times x. X times x equals x to the second. I'm going backwards, right? How come? If there's no exponent, you have 1 as an exponent, and 1 plus 1 is 2. Okay? Let's say that I have x to the second times x cubed. What is this? X to the second technically is x times x. X cubed is x times x times x, right? And how many x's I have? 5. So x squared times x cubed is the same as x to the 5th power, which is basically adding the exponents. What about when we divide it? Let's say that we have the quotient rule, which is division. Let's say that I have on the top x cubed over x squared. Remember, what's x cubed? X times x times x. X squared, x times x. Okay, so we're rationalizing here, and then we know that we can simplify those. 1x from the top, 1x from the bottom. X, x. How many x are left? Only 1. So x cubed divided by x squared is x. If there's only 1x, I have it x to the 1st power. Now let's talk about the quotient rule. The quotient rule says that when I'm dividing 2 powers with the same base, I subtract the exponents. Let's say that I have, example, let's say that I have x to the 5th power divided by x squared. Okay, remember, x to the 5th power says 1, 2, 3, 4, 5. Okay, divided by x squared is 2 of them. Now, if I can simplify those, 1, 1, 1, 1, how many are left? 3. Therefore, I have x cubed. And that's my quotient rule. Technically, I keep the same base, I subtract the exponents. Now, let's use this rule to explain another rule. What if I have, let's say, x to the 3rd power over x to the 3rd power? What's going to happen? Right? 3 of them on the top and 3 of them on the bottom. Let's simplify. 1 on the top, 1 on the bottom. 1 on the top, 1 on the bottom. 1 on the top, 1 on the bottom. They're gone. What's left? So to know what's left, let's pretend that I have the same thing, but in just 2 numbers. Let's say that I have 3 divided by 3. 3 divided by 3 is 1. If I cancel 3 from the top and 3 from the bottom, my answer will be 1. So when I cancel all of those, my answer here should be 1. So x to the 3rd divided by x to the 3rd is x to the 1. I'm sorry, it's 1. So using my quotient rule, if I have x cubed divided by x cubed, what do? I keep my same base and I subtract the exponents. Therefore, I have x, 3 minus 3 is 0. But we know already that it's 1. So x to the 0 is 1. Anything to the 0 power becomes 1. And that's the 0 property rule. Okay? So we have the product, we have the quotient, and now we have the 0. Now let's use the quotient rule to prove another property. When I'm dividing, I subtract the exponents.
much is my answer? X to the negative first power. But let's break this down. I have x to the second over x to the third is the same as x times x, and in the bottom I have 3x's. If I reduce this, I'll have at the end 1 over x, right? X in the denominator. So that's telling me that when I have a negative exponent, what I do is I flip. I bring it down. Okay? So if I have x to the negative second power, then what I do is I bring the negative exponent to the bottom. As soon as I move the power, my negative is gone. What about if I have that negative exponent in the bottom? So let's say that I have 1 over x to the negative second power. What happens is I move it to the top. As soon as I move it to the top, my sign changes. Okay, 1 was there, 1 times that is the same thing. And there's nothing on the bottom, I just put a 1, so basically my answer is x to the second power. What about if I have something on the top? Let's say that I have 3 over x to the negative fourth power. 3 is on the top, it stays on the top. And because this one has a negative exponent, it goes to the top, and those two will multiply. So my final answer is 3x to the fourth power. Now let's work in our last properties. So let's pretend that I have x to the second to the third power. Okay, this is called the power of a power. If I have two exponents, what happens is I multiply them. So it's going to be x 2 times 3, which is x to the sixth power. I can explain this easily. Remember, my exponent tells me how many times this is repeating. So basically what it is telling me is that I have 3 groups of x to the second power, right? And now we know from previous properties that when I multiply powers with the same base, I add the exponents. Therefore, 2 plus 2 plus 2 gives me 6, and it's the same answer. Okay, what happens if I have a product inside? Let's say that I have x squared y cubed, everything to the fourth power. So that exponent will affect each one of them, okay? So basically, it's like having x to the second to the fourth, and then y to the third to the fourth. So that exponent is going to multiply each one of them. Therefore, 2 times 4 is 8, and y is 12, okay? And this is a power of a power. What about if I have a division? Let's say that I have x squared y cubed, everything to the fifth power. It doesn't matter, as long as I have a parenthesis and an exponent on the outside, that exponent will affect every single term on the inside, okay? And the exponent will multiply. Therefore, I have 2 times 5 is 10, and y 3 times 5 is 15, okay? Now, let's work on a couple problems using all those properties. So let's say they have this example. Now, a common mistake that we have is that we start multiplying everything, or just combining exponents and all that stuff. So if you have a leading coefficient, if you have a coefficient in front of that term, they multiply straightforward, okay? So if you have negative 4 times 3, that's going to give you negative 12. Then the x's with the x's, x to the second times x, there's no exponent. You have a 1. So x squared times x, you add the exponents. 2 plus 1 is 3. And again, here's a y. There's no exponent on the y. You have a 1. So y to the first times y to the fourth power is y to the fifth power. Okay? Now let's go back to a couple of examples from zero exponent. What about have x, y to the second, everything to the 0 power? If you notice, that 0 is covering the whole parenthesis. So everything is to the 0 power, therefore is 1. Oh, let's pretend that you forgot that. So let's affect that. So let's affect the 0 exponent times every single one on the inside. So here I'll have 1 times 0 is 0, 2 times 0 is 0. Remember, the x and the y are multiplying. X to the 0 power is 1, times y to the 0 power is 1. And 1 times 1, most of the times is 1. Okay? Alright. What about if I have something else? Let's say that I have 3x to the third y to the 0 power. Is everything becomes 1? No, only the y has a 0 exponent. Therefore, that's the only one that is being affected. The 3 technically has a 1 as the exponent, stays the same. X has a 3, but the y has a 0. Therefore, this turns into 1. And 3x cubed times 1 is 3x cubed. Okay? And that'll be it. Now let's work on one with negative exponents. So let's say that I have a 8x to the negative 7, y to the 5th power, divided by 2x to the 7th power, y to the 2nd. Common mistake, because people are getting used to subtract the exponents. They'll say, oh, 8 minus 2 is 6. No, when you have coefficients, numbers in front of the variables, those divide or multiply regularly. So 8 divided by 2 is 4. Now here I have x to the negative 7 on the top minus the exponent from the bottom. Remember, it's the exponent from the top minus the exponent from the bottom. Keep that in mind, okay? 4, negative 7 minus 7, negative 14, and then the y, 5 minus 2, is 3. At the end, the last thing that you want to do is double check if you have negative exponents. If you do, you make a bar, a fraction. Whatever has a negative exponent goes to the bottom. The other ones that have positive exponents stay on the top. And that'll be your final answer. Alright guys, don't forget to subscribe, like the video, comment. Tell me if this format better or worse. Let me know. Alright? Comment on the comment section. Alright. Thank you for watching. I'll see you in the next one. Bye bye.